live there?
Yeah, we're live on YouTube, and so it's just to record on your.
Yeah, setting that up. It's
Yeah.
there. Finally, the control bar locks up while you're doing all that. Okay, now we're recording. Very good. Okay. Hello, everyone. We're going to do a little different lecture today. Remember, all right, we're going through linear algebra, but we're also learning Python as we go. Well, most of you know Python. What I mean is we're learning more Python, but in the sense of how do we apply Python to linear algebra type calculations, but also very importantly, how do we visualize them with Python tools? And a tool I've been using for over 20 years now is called Visual Python. And I wanted to show you how to visualize the cross product in that. So here I have, and let me know if I need to make this go still bigger, but this is VS Code. Let's see if I can just move this over a little bit for us. Actually, let's move it to another screen. And I'm just in a fresh, empty directory. So I'm going to create a new file, and I'm just going to call it cross product. And I'll try to spell it correctly. And then, so if we're going to use Visual Python, and oh, I should show, in case you haven't used it before, I'm sorry, I'm having to move some windows around. Let me show you how to get to it. So I'll bring a browser window over here. And let me make this bigger for y'all. We'll go to just Visual Python. And if you guys want, we could do an intro to it, but frankly, I think if you go through their site here, you'll end up doing quite well. vPython.org, short for Visual Python. And that's what we're using. But I'll give you a good intro to it here with what we're going to do together today. Okay. We can bring that back between it. So just like you have something like this, import NumPy as NP. And of course, y'all are already familiar with this. Oh, you see this problem right here? That means I'm not in the Python environment that I should be. So I'm going to select interpreter. And this is the one that I keep running with all of the modules installed through pip that I need. So you'll see here in a moment, that squiggly line will go away. And then import vPython as VP. Now, you don't have to do that. You could say from vPython import asterisk. I don't like that because I'm often mixing environments, mixing imports that might have the same method names. So I don't like to do the import something as asterisk. Sometimes I do it depending on what mode I'm in. But now that we have vPython at our hands, let's define just a vector. We'll call this v1. It'll be vp.vector. So pretty handy. And we're just going to define one in the x direction. So vector takes in 3 parameters, an x, y, and z. And oh, I should show you, if you want quick reference, you can, let's see, oh, bummer. Web, Python, let's see, documentation. pretty sure this, yeah, excellent. You go to the documentation and you can look at all sorts of things from an object standpoint, from a 3D object standpoint. And here's vector operations. And you could learn just what I'm doing right here. So here's the documentation, and I'll keep that handy in case we need to look at it, but I'm going to pull it out off the screen and we'll keep going. Well, right now, I've pretty much defined something to draw already. Well, that's interesting. Let's just see what will happen. So I'll go ahead and, by the way, I'm not doing PEP8. If I were doing PEP8, I would have done that. I'm just doing it so we see more on the screen, but it's good to follow PEP8. Okay, I'll run this. And nothing showed up on the screen like I expected it to. But I'm trying to think why. I really thought something would show up with just that little bit. Oh, that's because that's just a numerical quantity. My bad. So to save a little time there, I'll show you what we would type next. I want an arrow. And so I'm just calling the arrow method from Visual Python or class. And I'm going to call it A1 after I instantiate it. And then there's a parameter in there called axis. I'm going to say, well, the axis is V1. And this is a vector. The axis is a vector. We're defining along what vector the axis of this arrow rides. And then we've got parameters for shaft width, whether it's round. If round is false, it's a square arrow. And then the color. But you can see that, red is not defined. It's got that squiggly mark under it. So let's define it. Whoa, we used a vector again. Yeah, that's what's cool about Visual Python. It's making you think in vectors a lot. So this is one of the many ways you can define red. However, let's just try something. I think this might also work. Red is also stored inside Visual Python. So we could have done it either way. But I'm going to just, so that it's on the screen, I'll leave that there. And then again, one blank line at the end. I'll close that. And let's try that again. See if I can get something on the screen. Uh-oh, it didn't like something. No attribute red. So it still didn't like it. I thought when the squiggly mark went away, it would be okay. Now it could be that I can get away with this. I'm just going to try it once because I've noticed there's several different ways to do things in Visual Python, and that did start a window for us. But and just to show you what happens, it opens a live window in a tab of the latest browser you've used, but you can see that it's not displaying anything yet. So I'll close that. That automatically closes our code. And it did give us a problem here. Color must be a vector. So there we go. We have it well known now. So I'll go ahead and move that back to where we had it. We've defined it now, and now red is that vector. All right. We finally should be able to show something now for our work. And sure enough, okay, and I'll show it to you. And we're going to be using this browser over and over. So now the great thing about Visual Python is I've got this window, and that's a nice little drawing, but I am now using my mouse right button to rotate this. And if I hit shift, excuse me, if I do shift and left button, I can pan this image. But notice it keeps perspective when we do that. And then I can do the middle button and, excuse me, the scroll button on the mouse and just zoom in and out on this arrow too. Well, okay, one arrow, that's nice, but that's not going to get us to the cross product, right? So I'll put that back over out of the way and we'll add to this program. So let's do, and again, I'm cheating. I don't want us to always do this, but I'm just trying to keep less vertical real estate on our code. And I'm going to create two new vectors, v2 and v3, but this one's going to be only, v2 is only going to be in the y direction, and v3 is only going to be in the z direction. Okay, and then we'd like different colors just to make that clear. So I'm going to define more colors for us using the vectors. By the way, I am just doing cutting and pasting. I obviously do not code that quickly. And then we just want to repeat the same thing for the arrows. So now I have 3 arrows, and I should expect these to be showing in the X, Y, and Z directions. So I'll go ahead and run that again and wait for our new window to show up. And boom, here we've got red, green, and blue pointing straight out of the scene until we rotate it, of course. And then I'll just pan that down a little bit with my shift left. Again, I'm rotating with just the right button, no extra keys. I can zoom in and out with the scroll button, and I can pan with the shift left button. But yeah, and it's nice, they leave just a left click when you're in this window. That doesn't do anything unless you've arranged some buttons down here. You can get quite sophisticated with numerical readouts and controls in Visual Python. So in case you can't tell, it's something I'm strongly encouraging you guys to take the time to learn and to go through that website. And again, we can have some special one-off courses to go through some fun things on Visual Python. Now, I can't show both at the same time, but when I close this terminal, which is this area, this is literally an open terminal here in VS Code. When I close that, it does close the browser tab. I just, with the way I'm presenting to y'all, I can't show them both at the same time. Now, the next thing we'd like to do is just illustrate the cross product. Okay. Well, if that's the case, I probably don't need to have this v3 definition. So just to check that, I'm gonna comment that out. But oh, you may be realizing, yeah, then we don't have a v3 here. So we'll go both ways. What I'm going to do instead is leave this so that doesn't cause us problems on our definition. And we'll see about getting rid of that later. But now what I'd like to do is just create v3 from a cross product. Well, what's really nice, let's just do v3c for v3 cross product is equal to some Visual Python function, but it's amazing. Visual Python inherits from numerical Python, and they have a cross product function. And it's possible, I haven't double checked. Hugo, if you would, please look up NumPy to see if it has a cross product. I'm pretty sure it's the same thing, but it'd be good to check.
I'm going to do that right now.
Excellent. Now, what I'm going to do is not show this right away, I'll come down here and I'll call this V3C instead, because it's going to be defined by this cross product. And then I'll go ahead and run this and we'll see what we get. Well, awesome. I get the same thing. And because they are 90 degrees, that is, excuse me, this is V1, this is V2, they're orthogonal to each other, normal to each other, perpendicular to each other, I get the maximum cross product. And when these are unit vectors, which they are in this case, this is also a unit vector, and that is in fact what it is. In fact, what would probably be good is if we just reported that this time. So let's do, let's print V3C. And we won't, it's going to bring up the same window again, but I just want to look at the output this time. And look at that. We've got 1, 0, 0 crossed with 0, 1, 0, and we get this 0, 0, 1. So that's awesome. And we could also do this. Let's close this and say, well, that's great. What is the type of V3C? And we should find that, yes, it's a visual Python vector or a NumPy vector. Okay, in this case, it's categorized as a vPython object, a CY vector, and dot vector. I don't know what the CY is for, but that's deep in its module work or class work. So that's great. We know that the cross product does, in fact, bring back a vector, and that the math operations are just as we would expect from good old linear algebra. Well, that's good, but that's very static. Wouldn't it be nice if I could look at all that dynamically? Well, you know me, I like to cheat. So I'm going to cheat now. I'm going to create some lists for us. One's going to be a value list. And look what I'm doing here. I'm saying range from 100 to negative 100. And we're going to step by negative 1. And then I'm going to add another list to that where, the range, I just then typecast that as a list. So it turns it into a literal list. And I do that again. Remember, this is going to stop at negative 99 the way we've got it. So then we add into that negative 100 all the way to 100. And you'll notice that, well, that'll stop at 99, true, but you'll see how it works out when we get it animating. And then I'm just doing a group of angles from 0 to 400, stepping by 1. So this is the A list, angle list. And I want to run this as a perpetual animation. So I'm just going to say while true. And when we're done, we can stop this animation. But let's just look at, let's just do one part of the animation. So for X in the value list, now this loop will go until we kill the program, but this loop will just go until it's run out of 400 values, starting from 100 to negative 100, or right before negative 100, and then from negative 100 up to 99. So it'll end when it's finished that. But when it's ended that and any other for loops we have, it'll come back and start everything over again. Now there's a thing in Visual Python called the rate command, and it's because our computers are so fast nowadays that if we didn't have that, the animation could be too fast. And we're just slowing it down because the calculations happen faster than we want the animation to. Now, this is really cool. you see I've got a vector v1, and I'm only referencing the x value from it. Very handy. And so then I'm going to say, I just want to go between 1 and -1. So since I'm going from 100 to almost -100 in vlist, well, actually all the way to -100 and back, I'm going to call, I'm going to take each of those values that I'm getting from x, for x in vlist, and I'm just going to divide it by 100. And back a few years ago, if I did this, I would get integers. I would have to make sure that I called x a float, and just to be extra careful, I make this a float. But now when you do division with integers, you get back a float now in Python. I'm actually kind of glad they made that change, but it took me some getting used to. Now, we're changing the vector, but will that change the arrow? No, it won't. So we need to adjust the axis of arrow 1. And how are we going to do that? Just by assigning it v1. Now, let's just do that much for now and see what happens. Let's see. Need to. Oh, I haven't finished though. Now this will still give us, it'll show us v1, v2, but v3, you can see we took that out. We don't need it. It's not being used anywhere. So let's do that. And we don't see it upsetting the editor any, so we're good. The editor would alert us that, hey, that's not being used. Or it's not been defined in this case. And so now we need to say, okay, I want v3c to be updated. And so I'm going to, v1 is changed. So I'm going to just have that change. But if we do that, that means that A3 is going to change too. So let's give some space here for the different things we're doing. These two are related, so we'll keep them together. Now we need A3 to be adjusted. And what do we want to adjust on it? Its axis. So we can reference it directly like this. And we're going to say it's V3C for the cross product. Okay, well, that's good. And wow, this should go on ahead and illustrate a little bit. So let me step back through what we've done. We've done our imports, we defined our vectors, we defined some colors, and then we say our third vector is going to be the cross product of the first and second vectors, and each of these get an arrow with these parameters. And then I created a list of things for us to run through. We haven't used a list yet, but we will. And right now we're just using vlist to change v1 in an animation with Visual Python. So I'll run that, and I'll bring this over so you can see what's happening. Okay, now we have to rotate to see what's happening to v3. Isn't that amazing? Well, that's pretty cool. But, and let's just stop and look at this for a minute and think about it. Go down a little bit. When x is negative, and if you use the right-hand rule, I hope y'all can see this. So if I use the right-hand rule, when x is over there negative, I cross it with y. And yes, in fact, the blue is pointing back according to the right-hand rule. But when x is positive and I cross it with y, z is negative, or the v3 is negative, excuse me, positive, like my right-hand rule shows me. So it's just reinforcing what we already know from the theory, but it helps us gain better intuition, I think, to see the animation. So I'll close that window and we'll add some more animation. for our edification. So I'll close this. Well, just to save some space, I'm going to cheat again, just so we can see more at once. So I'll do this. And when I say cheat, I'm meaning in the sense of PEP8, right? Because PEP8 wouldn't want us to do that. But we're going to keep this as a group. And so now we have this one. A little trick here. QEN would be proud of me for showing you this. I'm holding the shift key and then hitting the down arrow, then hitting the home key, then hitting delete. It's a nice way to bring things around on one line when you need to. Well, that's really compact. Let's go do the same thing for Y. So to be constructively lazy, I will just copy and paste. But now this time, I'm going to say Y. And I do want the rate control again. But this time, we're going to change V2. We're only going to change the Y. We're going to say Y divided by 100. And then now this is arrow 2 is updated by V2, the arrow 2 axis. But the cross product, still the cross product of V1 and V2. So we do that again. And then, yes, we still have to update the A3 arrow axis with the V3 cross product. And we can do that much animation now. So I will go ahead and start this and quickly drag our window over that we know it's going to start in. Okay, again, got to rotate to see it. But it's going to run all the way through X first, and then it's going to run through Y. And if you can torch your wrist and your arm and your hand enough, you'll see that this is indeed following the right-hand rule when you do it for Y also. So when Y is negative, I've got to get my X over here, and I cross it with the Y that's negative. And yes, in fact, the Z goes into the screen. The blue goes into the screen. Okay, awesome. Great visualization. All right, get that back out of the way and go further. Okay. Well, now I'd like to run through the angles. Let's develop that a little more slowly. For A in A list. So that'll grab each angle from there. But I don't know any angles that go from 0 to 400. What are you doing, Tom? Oh, patience, my young Padawans. We will get there. Okay. Now, I'll rotate scroll this up just so we can see more. I'll keep this spread out, and then we'll make it smaller again. Now, this is the great feature of vPython. What we're going to do is rotate the vector, but it actually will return a whole different vector. We're just going to reassign it on itself. So we're going to rotate that X vector, and we're going to give it an angle. We'll say angle equals numpy.py. I can just grab the value of pi from numpy as np.py. It's very handy. And I'm going to go 200. I'm going to divide it by 200. And what does this mean? It means that as I go all the way through my A list, which you can see up here is 0 to 400, when I go through that whole list, I will have gone from 0 to 2 pi, but in increments of 1/200th at a time. So that's all I'm doing here. Nothing fancy, just making it fractional values. But one thing I am doing is saying the original axis of, the axis that this rotation is going to happen about is a vector that we need to define. And that vector, we can't use V1 because we're going to rotate it. So we have to just define, or we can't use any of the predefined vectors. Oh, but wait, Tom, you could. Yes. Why don't we've kind of done something like this upstairs, and we could just keep it constant. Let's define a VZ. We'll scroll back up here, and this guy that we had, let's just make him VZ so we don't have to call vp.vector every time for this thing here. It's just less computational power to not have to call this every time. So now I have this defined as a constant vector about which vectors can rotate. All right, so we'll scroll back up. Now we've got that a bit cleaner. And what do I want to do next? Well, if I'm going to change V1, what is that going to change? That is going to change the A1, or we want it to change the A1 dot axis, the arrow 1 axis, the length. So we're going to just say, well, that's V1. Okay, good. Then we still need that cross product updated. So I am going, and we know we need to update the A3 arrow. So I will just come down here and we'll do it that way again too. So, oh, sorry. Let's keep this stuff spread out for now. Okay, I've got the rate. I've got the V1 being changed, but it's by rotating it. Then I'm updating the arrow 1 axis accordingly. And then we know because V1 is changing an angle, that's going to affect the cross product. And we'll see how soon, in case you don't remember. Oh, wow, we're already ready to go. So I'll drag our window over really quickly again. Oh, sweet. But we need to rotate to see what's going on. So it's going through the first two. There's the Y vector changing. Now next what will happen? The X will rotate. And look at that. When they are pointing in the same direction or the exact opposite direction, the cross product's 0. And we could turn off the other two for loops and just watch the rotation. And if that would help you to get more intuition about what's going on, I strongly encourage you to do that with the code on your own. But notice when X is pointing the perfect negative direction, it maxes out in the negative direction. When X is maxed out in the positive X direction, the Z is its positive max, etc. All right, well, it may seem redundant, but I think it would be great if we repeat what we just did for rotating the Y vector. So I'm going to compact all this so we have more visual room. And we'll just get this compacted. Oh, okay. Again, just hitting the shift down arrow, home button while I'm still holding shift, and then hit delete. Not shift delete, just delete. Okay, great. Well, now we can do similarly what we did for Y, but we're going to just redefine all this for, yeah, we still want to go through each A and A list, but this time it's all going to be for V2. Now, I'm going to hold the control button and click with my mouse over and over because I need to change these to 2s. And those are the ones I need to change. So I'm hitting delete once and typing 2 once, and boom, it's all updated. We didn't want to change the 3s because we still want the cross product. Okay, so what are we going to see? X is going to cycle, Y is going to cycle, then the V1 X is going to rotate. So it's not X anymore. It's V1 rotating. And then V2 is going to rotate. But just so we don't have to watch all that initial stuff, and even more so, I'm highlighting enough to hit Control/ to comment all of those out. And Jeremy, I noticed you showed up. I love Colab and I love NAS, but I can't say in NAS, if it's possible to do those kind of operations, I just know I can't do that in Colab, and it annoys me. So if NAS could make NAS notebooks, yeah, thank you. If NAS notebooks could do that, oh man, that'd be a game changer. If it could do all the powerful editing that an IDE like VS Code could do. So what I'm doing, Jeremy, it's the idea of doing multiple cursor. Let me show you what I mean. If I click there, okay, that's one cursor. But if I hold the Control key and click again, boom, I'm creating multiple cursors, and I can move them together. I can go to the ends of lines and home together. But wait, there's more. I can even do Control-Shift, and I can highlight a rectangle. And that has immense power. Now, one thing it does do, Jeremy, which is good, I can highlight rate and Control-Shift-L. Now I'm changing a bunch of things together. So the notebooks, from what I've seen, will do that. Now, the other thing I haven't checked, Jeremy, is if I'm in a notebook in VS Code, I think I can do all this same stuff. So that's a big plus for doing notebooks in VS Code. But I'm guessing, Jeremy, that you could put a NAS notebook in VS Code. I don't know. It'd be good to know that too. All right, so we're just going to look at this V2 vector in this animation. And yes, we're just looking at the V2. Okay, good, Jeremy. I'm really glad you came to this one. This isn't the mentoring session. It's just our linear algebra class, but it's fun that you showed up to this one. All right, great. So this has the added advantage of we get to, just watch it like a clock now. And so you could do that with any of the other operations in these for loops that we created, guys. You could, just highlight one at a time. Better yet, you could put all of these inside each of these inside its own if statement, and then define what group of things you want to see outside this while loop. But now we've got everything. Well, that's great. Let's look at it all together. And we can increase the rate, but I have it going a little on the slow side so you can really see what's going on. And I will make that a little smaller for you. And here we come up on the X rotation, the V1 rotation. As soon as it rotates off the X axis, it's not X, it's V1. The V2, and again, V3 it's beholden to the other two because it's the cross product. Okay. Now, when you're learning and you're teaching, you can imagine creating this code and really illustrating this and working hard to get it right. Now, I confess, years ago, I couldn't have coded this up nearly as quickly. But if I had seen this after I learned cross products as a freshman in undergrad in physics, this would have made sense to me, but it would have helped me so much being new to it. Yeah, and by the way, we're just scratching the surface here of what we can do in linear algebra with Visual Python. So this is really great. Now, let's fast forward to some other cool things you can do here to make it even more clear. I've been holding back on y'all. I'm going to just add the rest of this stuff very quickly. I'm going to come up here where we had the arrows defined. I'm going to put a new group of stuff. These capital T's, they're just for text. And you can see we're calling text. We're saying what the text is going to be, how it's going to align. Then we're saying what color it's going to be. Oh, red, green. We want this one to be blue. Oh, but I think I defined it as blue, B-L-U. We've got a height of the text, and then we're saying where it's positioned. So notice that's a separate line because I've got the semicolon. V1 capital T dot position equals 1.1 away in the alignment that I defined. So you'll see how this is going to work. And then this one, I'm going to leave this one undefined for now, and we'll fix it below. So let me close this. So to each of these, to have that text handy, we're going to have to update that. So just for time's sake, I'm going to cut and paste those in. So the only ones we're changing here in this for loop are V1 and V3. And then the only ones we're changing, same thing, really. In fact, I won't even cut and paste from my original code. I'm just going to copy that, and I'm going to do that trick again. Control, click, and I'll change them both at the same time. Boom. Okay. Now down here, same thing, but well, I don't have to change anything because as V1 updates by rotation, I'm just still having it 1.1 away from the tip of the vector, which is super handy, as you'll see. Yeah, the text positions are just still in the same position. But here, I got to do that trick I did above again. We want these to be V2. So control. Oh, there we go. Man. Oh, I'm doing the wrong key. No wonder. There we go. All right. And 2. Okay, so that way, even if Thom says something wrong while he's talking, which is quite possible, it comforts me that even Saul Khan makes mistakes in things he's saying. And he's a great teacher. Sorry. Now we have this all labeled if we watch it rotate. So that's super powerful that we can add text, labeled text to our animations that moves with the physical objects. Now, what's great about Visual Python, now I love Manim. I think it's super powerful. I'm not saying you can't equate the physics to animations we do in Manim, but when you're working in Visual Python, it's like working in NumPy with animations. And so any physics that you're coding up or any data science that you're coding up, the animations are directly related to the math you're coding. Just you deal with a little bit of uniqueness that happens with Visual Python. All right. I hope y'all are loving this. I know I would if I were you, but then I'm an insufferable geek. Y'all are maybe just geeks at this point, but trust me, you will be assimilated. Okay. Well, that's all great. But what about, oh, and let me see too. Jeremy, thanks for, oh, Hugo. NumPy.cross. Excellent. Thank you for that, Hugo. I looked right over that earlier. Excellent. Thank you for putting that in the chat. So yeah, they're the same. And I'm sure that Visual Python probably inherits this from NumPy or numerical Python. Okay. Well, that is Visual Python for cross products. And if you want, guys, I'd like to show you just a little bit more in Manim. Now, I didn't get all the way through with Manim yet. I hope to finish it today. But let's look at what you do with Manim. Now, Manim, I hope it's easy for y'all to install. I found it easy to install. I wanted to use the LaTeX, so I'm also, I did the big install for LaTeX on this machine, which I'd done previously, but I had since obliterated this whole machine and start over. But I'm gonna just move this out. Hang on 1 second, I got it in form. I'm gonna go on mute a second. Okay, so now we're looking at Manim. And this is, but Manim's really cool. It's the tool that 3 Blue 1 Brown channel uses. If you've never seen that, it's a phenomenal channel on YouTube that the guy seeks to, I think it's Brian Sanderson, I might be saying it wrong, but more importantly, 3 Blue 1 Brown, his channel does amazing instruction for machine learning of all kind and using amazing visualizations. And I think he is the creator of Manim. But Manim's a community. I found that Manim feels pretty easy to learn at first, and then as you get deeper into it, it almost feels more like Java. You know, a lot of extra commands you got to go learn. It doesn't build up from principles quite the same as something like Python, but still good. So I'm going to go, I just want to get to a place where I can open the video. Oh, that won't be necessary. Hang on. I've got to find something's acting strange on my machine, and I'm struggling to get back to Windows because I'll get it for you. Hang on. I'm looking for a certain terminal window that's already open. That's not it. Okay. I may, for convenience, have to just reopen it. I think that's what I'll do. So I'm over in vectors. Oh, sorry, I'm speaking to myself. I'm just opening a new terminal so we don't have to worry about that.
Sorry, that is this Corel or what app is that?
Oh, right here?
Yeah, the one that had the JPEG.
Oh, this is Inkscape. And this is where I made
okay.
Yeah, I just, Jeremy, you might appreciate this. When I made that graphic for my post about you coming to speak to our integrated mentoring time, this is the tool I use for those types of graphics.
All right.
Okay, so here's my Linux terminal. I love your lightning bolt emojis. That's awesome. And so I'll be using that and showing you how I'm using it before I use it. But this file is just called scene, and it's I devote each animation in Manim to its own directory, unlike Visual Python. So just to show you, I'm down here in my directory structure under Manim. I have several animations I've been practicing. And then under the vector ones is where we get to just a huge, deep structure. We could visualize that a different way, but I'm not going to bore y'all with that. What I do want to show y'all is how we use this terminal window, and you could do this in Windows once you get it set up. And I'll just show you where I've gotten with Manim so far. But boy, did I really have to think different in Manim. Manim is literally a bunch of individual scenes stitched together. It doesn't do a real-time video. It renders it very well. It renders it as quickly as it can, and then it stitches those images together in a video. So I'll pull that terminal window out of the way and just walk you through this. This is very much like what we just did in Visual Python. Some aspects of it are easier and some are harder. But notice I define my own class and I inherit from the scene class in Manim because I've imported everything. I gave up on that. I think I would really like to call this import Manim as ma and then do ma.scene, etc. But for my learning, I decided not to. Now I had to do this initiate arrows and really the plane too over and over again. So notice I'm returning 5 values from this class method. And here's the class method. I'm just drawing or arrows from the origin. This is already predefined in Manim. And each of these vectors is in these respective directions. But what I had to do, unlike, you noticed I could scale my objects, just like Saul Kahn taught us about using scalars on vectors. But Manim's a bit different. I'm actually transforming. And if I didn't clear the scene, the last showing of x arrow 1 or x arrow 2 would obscure this scene. So I'm literally clearing the scene after doing these operations and starting completely over. But so far, that was the best way I could find to do it. And so at the bottom of what I've learned to do is at the bottom of each of these files, I store what I'm going to put in my command line. So I'm just copying and pasting that there. And then it's literally going to, the way Manim works is when it sees this, it will, these flags right here means it's going to automatically play it for the little p. I'm sorry, let me make that bigger. Oh, let's see. Remember. You. Oh, okay. No, I was doing it right. I just Control plus. There we go. Fine. Okay, I hope that's big enough. So the P is for play, and the QL is for quality low. We'll just run that, and oh, okay. Can anyone guess why that didn't work? This will test y'all. It will work, but not until I do something.
Is it a Linux command? Because I am not a Linux guy.
No, it could have been the same issue in Windows. Well, it's because my system Python does not have Manim installed, but my virtual environment called Py38 standard does. And oh, great. Now it's reminding me that I am running in the Py38 standard for anything Python I do. It will be in that environment now. So now I can run this and you can see what's going to happen. It's doing some rendering statements and thank God it worked. And you can see that boom, but I can't rotate this. It's not 3D yet. And I just paused it unintentionally. But at least I have all of these parts working. Now I just have to put it in a 3D environment. And that's where I'm at now in my learning. Some of the educational materials I'm using are out of date. The Manim documentation is both good and bad. It's good when you're learning the very basics, but as soon as you try to go to something more advanced, there's some great YouTube tutorials, and those producers are really good about showing their code in GitHub. But as Manim is updated, they have not updated their GitHubs, and so I'm having to troubleshoot their code so I can understand the next step. But I think I'm very close to having it working. And what I will do is put these in a notebook put in our notebook, but make a special point that these probably will not run inside Google Colab or inside a notebook. And I do hope to move to NAS notebooks soon. Jeremy, is there a way for us to, I guess right now you would put your notebook code on a GitHub repo, correct? And you can come off mute or answer in the chat. Okay, so guys.
Yeah, sure.
Okay, very good. After we hear Jeremy today, starting just a little less than an hour from now, we might in fact want to start doing that, but we can do both. I might do both. I know we were sure sold by Dean about DAG's Hub last Saturday. All right, let me give you all some downtime before we start mentoring. So that gives you more than 50 minutes. And before I'm going to stop sharing, and I can reshare if necessary. But for now, I'll stop sharing, and I'll bring my window back over and just see if anyone has any questions. And then Hugo and I will be the last two to hang up. So if you don't have any questions, now's the time to hang up. And I think, yeah, now's the time to hang up. And then, but if you do want to hang back for questions or discussion, I'll be the last to hang up. All right, Ayodeji, really great to have you, buddy. See you in mentoring, I hope. All right, Jeremy, see you in mentoring. We're really glad you're coming today. All right, good. And hey, Hugo, how'd that go?
Yeah, that went well.